Hi, my name is Can Tuzla, and I'm a product manager on Oracle Autonomous Database team. I've been with Oracle for the past 8 years and a little over 8 years actually. And I actually before I joined Autonomous Database, I also worked in Oracle multi-tenant and optimizer teams as well. And I'm happy to actually join you guys today to talk about how to easily access external data sources and making web service calls from your Autonomous Database. So before we actually dive into our main topic today, I want to actually cover a little bit of background on Autonomous Database, specifically about what it really is and what makes it special, what makes it a special offering from Oracle. And this starts with actually many years ago when Oracle first started automating database operations, like the database activities or like database functionalities, starting with version 9i. And there are many improvements have been made in this area. And similarly, we've been also heavily investing in infrastructure automation for the past 15, 16 years. And Autonomous Database just brings these two together and then basically completes this journey for us. And adds on top of this, it adds automated data center operations with machine learning. So what does this mean exactly for you as the end user or the customer? So this means that you are actually able to take full advantage of this entire automation and full database lifecycle management. 100% is automated in Autonomous Database, including provisioning, cloning, and database backups, upgrades, and so on. This basically eliminates all the complexity, even for complex and mission-critical databases with sensitive data. Before I again move on, I want to also touch base on a couple other strengths of Autonomous Database. And in these two specific areas, like namely elastic scalability with no downtime that comes again built in Autonomous Database. Similarly, built-in security, which encrypts all data by default, again, included in Oracle Database. And we not only encrypt data at rest, we encrypt all data in transit as well. Therefore, all these things combined together allows you to innovate more, pay less, and ensure data safety for you. When we are talking about Autonomous Database, it's definitely worth mentioning the workload types that it specializes in as well. Autonomous Database is a single product, but it is actually optimized and specialized in specific workload types. So we have here first Autonomous Data Warehouse, which actually is specifically targeted for decision support and data warehousing like workloads that require fast queries over high volumes of data. And we also support transactional workloads that require fast responses over transactional workloads for short-running queries and again, transactions. Similarly, if you are interested in low-code application development, we have Oracle Apex. And last but not least, Oracle JSON offers document-centric application development if you are doing any document store development, and if you need to do any application development around JSON-centric applications, then Autonomous JSON is the perfect fit with its friendly document store APIs as well as native JSON storage. Before I again move on to our main topic, the last thing I want to talk about Autonomous Database is the deployment options. Autonomous Database can basically run everywhere. You can either use the same service in our public cloud, or you can use the same Autonomous Database service on-premises with our Exadata Cloud at Customer and dedicated region Cloud at Customer models. Hopefully you found this quick recap about Autonomous Database helpful. And before again we start diving deep into our main topic, I want to briefly talk about our agenda for this session. So we'll start our main topic by talking about accessing cloud resources and how autonomous database makes this easy with principle-based authentication methods, not only for OCI, but also for Azure, AWS, and GCP. And we are also going to talk about how you can take advantage of this principal authentication when you're doing some common operations such as loading data from object stores or creating or querying external tables that are actually built over external data files that reside in different cloud object storages. Our next stop is going to be accessing other databases. Specifically, we are going to be focusing on accessing non-Oracle databases and the innovations that Oracle Autonomous Database has brought in this area. And we are going to see how actually easily you can access a non-Oracle database. And we'll see how seamless and painless that experience is. It's just as easy as accessing another Oracle database, basically. And we'll see how you can achieve this. Our last stop is going to be calling web services, which is another hot topic, actually, for database users. Whether you're accessing a web service that's deployed on public endpoint or private endpoint, we'll make sure to cover both options, both use cases, and we'll see basically what practices Autonomous Database adopts and basically what options you have when it comes to interacting with web services. So let's start with accessing cloud resources. Autonomous Database supports principle-based authentication when you're accessing cloud resources. And not only for OCI, as I mentioned, we also support the same methodology for Azure, AWS, and GCP as well. Before I actually go further into why principal authentication is important and how you can use it, I want to talk about what it really is and then how it really differs from other methods of accessing cloud resources. In your day-to-day operations or in your day-to-day life at work, you might be actually loading data from different cloud object stores. You might be creating external tables within your database. And when you do these operations, your database needs to be authenticated against the cloud service. And one way to achieve this is to basically store your data, store your cloud credentials in your database, whether it's username and auth token or whether it's username and password. You can do it that way. And obviously, it's not ideal because you don't want to store the database credentials in your database all the time for various reasons, and most importantly, for security reasons. And another option, actually, that eliminates this hurdle is using principal authentication. In this approach, you do not need to actually store any user credentials in your database. Database itself is basically used as a certificate or a token that gets refreshed frequently against the database against cloud services, object storage, for instance. So when you're accessing an OCI object storage, that token or that certificate is used by your database to access that resource. And the cloud service on OCI end, or whether it's Azure, OCI, or AWS, basically checks if your database, if your resource, in this case, has privileges or the policies defined to access that resource. So basically, it's a mutual handshake done through this way of authentication, what we call principle-based authentication. Another great benefit of this approach is granular access control management. As I said, just because you enable this authentication in your database does not mean that your database all of a sudden becomes powerful enough to access any cloud resources, which is not the case. You need to also define dynamic groups or policies on IAM side in OCI, for instance, or in Azure or on AWS that basically defines the scope of this authentication. So you can easily say, hey, I want my database to only access this specific bucket in my object storage, and I want my database to only read, for instance, objects. I don't want any write privileges for this database. It's totally doable. It's totally possible. And Last but not least, we also enable our users to use this, take advantage of principal authentication via a single API for all cloud providers. So in your autonomous database, you can enable this method of authentication for OCI, Azure, AWS, and GCP using the same PL/SQL API. Now that we learned about resource principal or service principal or principal authentication in general, let's talk about how we can use this. Instead of just covering it with words, I actually want to show you guys a live example here on how I would basically be defining my policies and dynamic groups to access an OCI object storage bucket, for instance, to load some data. So in this example, we are going to be focusing on OCI object storage, and in a couple of minutes, I'll actually repeat the same exercise for Azure Blob Storage as well. Our first step is going to be about creating a dynamic group and a policy. And we are creating a dynamic group here, basically defined by a resource ID and offset, and it basically involves a single autonomous database in this case. Of course, if you want our dynamic group, basically we can make it even at a larger scope as well. It can include the resources of an entire compartment or entire tenancy as well. And second part of our dynamic group and policy creation is the policy. And as you can see here, I'm actually creating, defining two policies that will allow this dynamic group to access the buckets and objects in this specific compartment called training. After I do this step, my next step is to basically enable this principal authentication. In OCI world, again, this is called resource principal. Basically, I'm enabling the resource principal authentication, and I enter OCI as my provider. And it's important to note that these enablement steps are just one-time operations. So in other words, you won't be repeating these every single time you have to reach a cloud resource in OCI or in Azure. So these are just pretty much one-time operations. Now that our resource principal is actually enabled, the next step for me actually is to load data from OCI object storage. And for this, I'm using our API, PL/SQL API called DBMS Cloud Copy Data. And this API, I have table name, and we are going to be loading into our table called channels. And we have credential name, our file URL, which basically points to our object storage bucket, and some formatting parameters. As you can see, as you probably already noticed, our credential name is OCI $resource principal, which is a very specific name, and it actually is the credential name that we need to use every time we want to access some OCI resource using resource principal. We will see actually this credential name changes from provider to provider. If we were to, for instance, use Azure, our credential name will be different, of course. Speaking of Azure, let's repeat the same exercise for Azure Blob Storage as well. Again, the same methodology here applies, meaning that we will be basically accessing Azure Blob Storage from our autonomous database, and our autonomous database still needs to authenticate itself against Azure Cloud. And in order to do this, our first step in this example is to enable principal authentication, and our example here shows that the provider name is Azure as expected, and we provide our Azure tenant ID in this example as well, so that our autonomous database can actually create certain metadata about this potential handshake that's going to happen in a little bit. And then the metadata that I'm talking about can actually easily be accessed in the Cloud Integrations view, database view that we have here. And this view creates certain entries once we enable the principal authentication. As you can see, we have the tenant ID, we have Azure consent URL, and Azure app name. Azure consent URL is what's important for this step here, which basically is a link, a URL that we will need to go to. And basically, as an Azure admin, Azure account admin, we need to approve this request that autonomous database basically will submit. And that will allow our autonomous database to access Azure resources. And the Azure app name is basically an application name for our autonomous database. It's important to point out that from Azure standpoint, our autonomous database is actually an application. So that's why Azure assigns an application name for this autonomous database. And this is the application name for our autonomous database that we will be using when interacting with Azure. As I mentioned, our next step is basically to follow that consent URL that we saw in previous step and accept it as an Azure Cloud admin. And steps 4A and 4B that we are going to see in a little bit are actually very similar to what we did with OCI resource principle approach, where we define some dynamic group and a bunch of policies basically on top of it. Here in Azure, they don't have the concept of dynamic group and policies, but the terminology is a little different. So they basically have members. A member is basically an entity that can access the specific resource, in this case, my cloud blob storage. So we are adding our autonomous database instance here as a member so that it will be able to actually reach this cloud storage. And role that comes in this step, assignment, a role assignment, is basically very similar to a policy. It basically defines what these members can do within this cloud blob storage. And as you can see, I basically chose only read access for my members. So our autonomous database will be able to read objects in this container. After this is basically pretty much the same story as OCI. We're basically using the same API, DBMS Cloud Copy Data. The credential name, as we mentioned earlier, is different. In this case, instead of OCI resource principle, we are using Azure $PA. And of course, our file URL is slightly different too, since we are actually using a Microsoft blob storage URL. And the rest is the same. Once we do this, our data is actually going to be coming through into our database. We'll be loading our table from the same file, basically. Loading data is actually is one example, but then another actual use case that is very common is for our database users is creating and querying external tables. And this is important because not all the time you want to load the data into your database. Sometimes you want to build external tables on top of files that are residing in remote locations in different cloud object stores, for instance. And for this, autonomous database actually support different file formats, such as CSV, TSV, JSON, Avro, ORC, and Parquet, for instance. And to further actually improve our efforts, or basically emphasize our efforts in multi-cloud to enable our customers to interact with different clouds easier, just like, or as if they're interacting with OCI, we actually support not only OCI object storage, we also support Azure Blob Storage, GitHub repository, or any AWS S3 compatible object storage for external tables. So you can basically create external tables over files that are on these object storage as well. On the right-hand side of the screen, basically, we are seeing an example of how to create an external table. We have table name that we specify. We have credential name, which we can actually use any principal-based authentication, again, here for this API as well. And we have our file URL. In this case, we are using a CSV file called weather report. And it has the file itself has some fields that we need to specify, which will later become columns in our table. Yeah, that's it. This is as easy as basically it gets when it comes to creating external tables, whether they are in OCI or AWS or Azure or GCP, it doesn't really matter. Accessing other databases is actually another important topic that we made a lot of strides in autonomous database. It's a very common actually methodology that people use when they are actually when they need to load data or query data that are located in different databases. And one of the most common approaches that is used is creating a database link for accessing other databases. And in this section, actually, I want to cover how easy it is to access non-Oracle databases from your Autonomous database. And I actually want to show you guys it is just as easy as accessing another Oracle database. Before we start, I just want to point out that the term heterogeneous connectivity is actually often used to describe any connections or any connectivity between an Oracle database and a non-Oracle database. So when you're accessing from Oracle to Snowflake, or when you're accessing from Oracle to the SQL Server, this is usually referred as heterogeneous connectivity. And this has been actually a valid use case, and there are various ways to accomplish this. One of the most common ways is actually known as database gateways. It has been around for a long time. You can basically deploy your database gateway that can be configured for each non-Oracle database. It is possible for Autonomous database as well, so you can deploy your database gateway for Autonomous database too. But the problem is that it's an involving process. So you have to basically figure out the setup, you have to configure it, you have to configure a wallet for the gateway, you have to configure the network. And if you want to access different non-Oracle databases, let's say AWS, Redshift, Snowflake, you have to do this like for each of these databases on your own. So what the innovation that we actually accomplished earlier this year is in Autonomous databases, built-in gateways to access non-Oracle databases. So instead of letting our users figure it out how to do this, how to deploy their gateways, we actually do it for you guys, and we basically deploy these gateways for these databases, non-Oracle databases, so you do not have to worry about that hassle, that burden at all. So namely, we support Microsoft Azure Synapse, AWS Redshift, MongoDB, MySQL, Postgres, Snowflake, Hive, and there are many other non-Oracle databases that are actually coming and will be supported hopefully very soon. The great thing about this feature or this capability is that you get to use the same database link API, DBMS Cloud Admin Create Database Link. So the process is actually almost exactly the same as creating database link to an Oracle database. Only difference that you see here is the parameter that's second from last, called gateway params, that basically lets you specify the database type that you're accessing. In this case, in this example, I am actually creating a database link for AWS Redshift, for instance. And this entire feature, this entire capability, of course, is included in your Autonomous database service. In other words, it's free of charge. You don't have to pay anything extra for this. That's another great part about it. So I highly recommend you checking out if you have use cases about accessing non-Oracle databases, whether you want to move data from Redshift to Oracle or Snowflake to Oracle, especially for small amounts of volumes of data. Highly recommend checking it out. So, as I said, another hot topic is calling web services. We often actually get asked by our users, our customers, that if Autonomous database supports calling web services. The answer is yes, of course, Autonomous database supports calling web services, and it supports calling web services not only to public hosts, but also to private hosts as well, as we are going to see in a little bit. But before we move on to that, I want to just give a brief background on how you can actually be calling web services from your Autonomous database. You basically have two options when it comes to APIs or packages. We support the package, which is very well known, util HTTP, if you are interacting from SQL or PSQL. Or if you're an Apex developer, if you do Apex development within your Oracle Autonomous database, you can also use Apex Web Service package as well. Both of these packages adopt our security-first approach, meaning that we highly prioritize the security when you're interacting with these web services. And in other words, we do not allow unsecure connections. All web service connections have to be secure, so you have to be using HTTPS. We do not allow HTTP or HTTP proxy. Similarly, we do not allow IP addresses for the same security-related reasons. When we talk about HTTPS, of course, this brings the question in mind about, like, what about wallets? When you're using HTTPS, of course, you have to use the wallet. And do I have to create my own wallet? How do I make sure that it includes all these certificates, this and that? So thankfully, you do not have to worry about it. Again, as I said, Autonomous Database is all about automation and simplicity. We actually provide a pre-configured Oracle wallet, which includes over 90 most commonly used trusted root and intermediate SSL certificates. So as long as your host, the target host, the web service that you're making a call to uses a certificate, a trusted root and intermediate SSL certificate, then you're good to go. So let's see actually how you can make a web service call in Autonomous Database. We'll start with the little easier use case, which is making a call to a public endpoint. In order to make a web service call to a host or a target that's deployed on a public endpoint, all we need to do pretty much just add this host to our network access control list, also known as ACL or ACL. And we do this by actually running this API or calling this API, IP SQL API called DBMS Network ACL admin, append host ACE, which basically appends an access control entry into our ACL with our host name. And the next step is to call util HTTP set wallet with no arguments. As I said, you do not have to configure any wallets. You do not have to modify the built-in wallet. This procedure basically just points out the location of the wallet to the API, so that the API actually knows where to look for the necessary certificates. And if you provide any arguments, they will be ignored. We won't be throwing any errors, but just it's good to know that you don't need to provide any arguments. The last step is basically submitting your web service call. In this case, we are running a util HTTP request call. That's pretty much it. So how do you access hosts on private endpoint? For this use case, let's assume you have an Autonomous Database that's on a private endpoint, and you want to access a web service that's deployed in your private network, which also has a private host name, basically, that you can access to from the same private network. So how do you do this? In order for Autonomous Database to know that this host name is actually private and it needs to be resolved in your VCN, you need to tell the Autonomous Database that this target is private. And in order to do this, the option one is to set private target parameter in DBMS Network ACL admin, append host ACE procedure, as we saw earlier. We just add the private target parameter and basically set it to value true. And the rest of the steps is exactly the same, basically. Option two is actually slightly more convenient, and especially if you're dealing with these private web service calls all the time, or if you're creating database links to other database in your private network, or if you're sending, let's say, emails to other or destinations within your private network, then you may not want to call this private target, or you may not want to set this private target parameter to true every single time when you call the API. So what you can do instead is that set route outbound connections database property to the value private underscore endpoint. And what this will do is that it will basically automatically route all outbound connections to your VCN by default. And all these connections, of course, will be subject to your VCN security rules. And this property, again, once it's set, it applies to database links, it applies to Apex Mail, Apex Web Service, or util HTTP, util SMTP, or DBMS LDAP, basically. And before I actually conclude this section, I want to point out that when we are dealing with private endpoints, it may be overlooked, but I want to again explicitly point it out that you need to make sure that actually not only to set these properties or parameters, but you also need to make sure that you have proper egress and ingress rules defined in your network. So for instance, when you're making a web service call from your autonomous database that's on private endpoint, you need to make sure your autonomous database can go out on port 443, which is the port number that util HTTP uses by default. Basically, you need to make sure that there's an egress rule defined for this port number for your autonomous database. Similarly, for the receiving end, which is the host, the target host, it needs to be able to ingress on port 443, basically. So you need to have both egress and ingress rules defined to be able to make this happen. Well, this brings me to the end of my presentation. I really enjoyed sharing the session with you guys, but before I conclude, I want to point out that if you guys are interested learning more about autonomous database, I highly recommend checking out a couple of links I dropped here. The first one is our autonomous database homepage, and the second one is about actually the blogs that we post. Most of the features that I covered here in this session also actually presented as a blog to our customers and users. So you can find it publicly available online. And most importantly, the last one is our documentation. All these concepts, features, the capabilities are explained even more in detail in our documentation. Thanks for joining me. Thank you.